circuit tracer can indeed assist in locating a neutral to ground short within an electrical circuit. Here's how a circuit tracer operates. Firstly, the device injects a distinct signal into the circuit wiring. Secondly, a handheld receiver is used to trace the path of that signal. The receiver is designed to detect the signal emitted by the tracer. Thirdly, as the receiver approaches the location of the short circuit, it provides an indication. This indication typically manifests as an audible beep or a visual light signal, alerting the user to the proximity of the fault. To utilize a circuit tracer effectively in identifying a neutral to ground short, follow these steps. 1. Turn off the power to the circuit at the breaker panel. This is a crucial safety measure to prevent electrical shock during the troubleshooting process. 2. Disconnect all devices and appliances from the circuit. This includes removing light bulbs from fixtures, unplugging appliances from receptacles, and disconnecting any other electrical loads connected to the circuit. 3. Set up the circuit tracer by connecting its transmitter to the circuit wiring. This typically involves connecting the transmitter to the hot and neutral wires of the circuit. Ensure that the connections are secure and properly insulated to prevent accidental shorts. 4. Turn on the power to the circuit at the breaker panel. This will energize the circuit and allow the tracer to send its signal through the wiring. 5. Begin tracing the circuit with the receiver. Hold the receiver and move it along the path of the circuit wiring, following the cables and conduits. Pay close attention to the receiver's indications. The receiver will emit a beep or light up as it gets closer to the location of the short circuit. 6. When the receiver indicates the proximity of the short, carefully examine the wiring and devices in that area. Look for any signs of damage, such as frayed insulation, loose connections, or burn marks. 7. Once you have located the exact point of the short circuit, you can proceed with the necessary repairs. This may involve replacing the faulty wiring, tightening loose connections, or replacing a damaged device. Ensure that all repairs are performed in accordance with local electrical codes and regulations. 8. After completing the repairs, test the circuit to ensure that the short circuit has been resolved. Use a multimeter or circuit tester to verify that there is no longer a connection between the neutral and ground wires. 9. Turn off the power to the circuit at the breaker panel. Disconnect all devices from the circuit. Set up the circuit tracer by connecting it to the circuit wiring. Turn on the power to the circuit. Trace the circuit with the receiver. The receiver will beep or light up when it gets close to the short. Once you have found the location of the short, you can repair it by replacing the faulty wiring or device. Ensure the power is off when performing the repair. When a ground fault circuit interrupter, or GFCI, trips without an apparent cause, it indicates that there is an unintended path for current to flow to ground. This situation can be dangerous and requires prompt attention. The scenario described involves a circuit that serves multiple locations and devices, including bedroom receptacles, bathroom lights and exhaust fans, a range hood fan, and a kitchen sink light. The fact that the circuit is protected by a GFCI breaker suggests that there is a heightened risk of ground faults, as GFCI devices are designed to detect even small imbalances in current flow. Given the layout of the circuit, there are several potential causes for the GFCI tripping. Firstly, moisture intrusion can create a conductive path between the neutral and ground wires. This is especially likely in bathrooms and kitchens, where water is frequently present. Secondly, damaged or deteriorated wiring can also lead to ground faults. Over time, the insulation on wires can crack or wear away, exposing the bare conductors and creating a path for current to leak to ground. Thirdly, faulty devices connected to the circuit can cause ground faults. Appliances and light fixtures can develop internal shorts that allow current to flow to ground. The use of a circuit tracer can greatly simplify the process of locating the ground fault. By injecting a signal into the circuit and tracing its path with a receiver, you can pinpoint the exact location of the fault. This eliminates the need for guesswork and reduces the amount of time required to troubleshoot the problem. When using a circuit tracer, it is important to follow all safety precautions. Always turn off the power to the circuit before connecting the tracer. Wear appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical circuits in wet or damp conditions. In addition to using a circuit tracer, there are other techniques that can be helpful in locating ground faults. One approach is to systematically disconnect devices from the circuit, one at a time, and see if the GFCI stops tripping. This can help you isolate the problem to a specific device or section of the circuit. Another technique is to use a multimeter to measure the resistance between the neutral and ground wires. A low resistance reading indicates that there is a conductive path between the two, which could be causing the GFCI to trip. When repairing a ground fault, it is important to use high-quality materials and follow all applicable electrical codes. Ensure that all wiring connections are tight and secure. Replace any damaged or deteriorated wiring, and properly ground all devices and appliances. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician to perform the repairs. Electrical work can be dangerous, and it is important to ensure that it is done safely and correctly. In summary, locating a neutral to ground short requires a systematic approach and the use of appropriate tools. A circuit tracer can be a valuable asset in this process, allowing you to quickly and accurately pinpoint the location of the fault. By following proper safety precautions and using sound troubleshooting techniques, you can resolve the problem and restore the circuit to proper working order. In a residential setting, ground faults can occur due to a variety of reasons, often related to the age of the wiring, environmental factors, or improper installations. For instance, older homes may have wiring that has deteriorated over time, leading to cracks or breaks in the insulation. This can expose the conductors and create a path for current to leak to ground, especially in areas where the wiring is exposed to moisture or physical stress. Similarly, improper installations, such as loose connections or damaged receptacles, can also create ground faults. If a wire becomes disconnected from a terminal or a receptacle is cracked or broken, it can provide a path for current to flow to ground. In some cases, ground faults can be caused by external factors, such as rodents chewing on the wiring or nails or screws piercing the insulation. These types of events can create a direct path for current to flow to ground, resulting in a ground fault. When troubleshooting a ground fault, it is important to consider all of these potential causes. Start by visually inspecting the wiring and devices connected to the circuit. Look for any signs of damage, such as frayed insulation, loose connections, or burn marks. Pay particular attention to areas where the wiring is exposed to moisture or physical stress. If you find any signs of damage, repair or replace the affected components as necessary. If the visual inspection does not reveal the cause of the ground fault, you may need to use a circuit tracer to further investigate the problem. A circuit tracer can help you pinpoint the exact location of the fault by injecting a signal into the circuit and tracing its path with a receiver. This can be especially helpful in situations where the wiring is concealed behind walls or ceilings. In addition to using a circuit tracer, you can also use a multimeter to measure the resistance between the neutral and ground wires. A low resistance reading indicates that there is a conductive path between the two, which could be causing the GFCI to trip. If you find a low resistance reading, you can use the multimeter to trace the path of the current and identify the source of the leak. When repairing a ground fault, it is important to follow all applicable electrical codes and regulations. Ensure that all wiring connections are tight and secure. Replace any damaged or deteriorated wiring, and properly ground all devices and appliances. If you are not comfortable working on electrical circuits, it is best to hire a qualified electrician to perform the repairs. Electrical work can be dangerous, and it is important to ensure that it is done safely and correctly. A reminder: turn off the power to the circuit at the breaker panel before beginning any work. Wear appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical circuits in wet or damp conditions. By following these precautions, you can minimize the risk of electrical shock and ensure that the repairs are done safely and effectively. The process of locating a ground fault can be challenging, but with the right tools and techniques, it is possible to identify and resolve the problem. By taking the time to troubleshoot the circuit carefully and methodically, you can ensure that it is safe and reliable. Electrical safety is paramount, and it is always best to err on the side of caution. If you are unsure about any aspect of the work, it is best to consult with a qualified electrician. The use of a circuit tracer involves specific steps to ensure accurate fault location. First, to energize the circuit by turning off the corresponding breaker at the electrical panel. This is a critical safety step to prevent electrical shock. Next, disconnect all devices and appliances from the circuit. This isolates the circuit and prevents interference from other components. Connect the circuit tracer's transmitter to the circuit wiring. Typically, this involves connecting the transmitter leads to the hot and neutral wires at a convenient point, such as an outlet or junction box. Ensure secure and proper connection. Energize the circuit by turning the breaker back on. This allows the tracer to send a signal through the wiring. Use the circuit tracer's receiver to trace the circuit. Start at the electrical panel and follow the wiring path, moving the receiver along the walls, floors, and ceilings. Listen for changes in the receiver's signal, such as beeping or changes in tone. These indicate the proximity of the fault. As the receiver gets closer to the fault, the signal will become stronger. Carefully examine the wiring and devices in that area. Look for signs of damage, such as frayed insulation, loose connections, or burn marks. Once the fault is located, de-energize the circuit again and make the necessary repairs. This may involve replacing damaged wiring, tightening loose connections, or replacing faulty devices. After the repairs are complete, test the circuit to ensure that the fault has been resolved. Use a multimeter to check for continuity between the neutral and ground wires. There should be no continuity, indicating that the short has been removed. Finally, re-energize the circuit and verify that the GFCI breaker no longer trips. This confirms that the ground fault has been successfully located and repaired. When using a circuit tracer, it is important to follow the manufacturer's instructions carefully. Different tracers may have different features and settings, so it is essential to understand how to use the specific model you are working with. Additionally, be aware of potential sources of interference that can affect the accuracy of the tracer. These may include metal objects, electrical equipment, and radio frequency signals. By taking these factors into account, you can improve the reliability of the tracer and ensure that you locate the fault quickly and efficiently. Remember, electrical work can be dangerous, so always prioritize safety. If you are not comfortable using a circuit tracer or performing electrical repairs, it is best to call a qualified electrician. They have the training and experience to handle these tasks safely and effectively.